Welcome back to Digital Electronics. Today we're going to be working on component identification, exercise 114. In here there are 4 things: a color-coded chart for reading a resistor, how to read a capacitor, there's the assignment, this, and there is a little PowerPoint that has some information about components. If you already know all the components, you can just go right to the assignment. I will go over the PowerPoint to talk very quickly about components. So resistors, this is the symbol. This is what they look like in reality. You read them left to right once you put them in the correct orientation. They slow down the flow of electrical current. In other words, they decrease the amps going through it. They are measured in ohms of resistance, which we've reviewed already. They look a couple different ways: 4 bands, 5 bands. Well, 5 bands are down here. These can change the resistance, and they look like this on a diagram. These are mounted on the surface. They are the same effect as these carbon film ones, except that this is what you'd find when a robot is soldering things like in a cell phone or a computer. Okay. So there's 2 ways to figure out their value. One is the color code, one is the multimeter. I will show you how to do both of those. So for this one right here, it looks like it's brown, green, green, gold. So brown 1, brown 1, green 5, green 100K, 1, 5, 15 times 100K. That would be 1.5 million ohms. And then it's got gold out here, 5% tolerance. So 1.5 million ohms with 5% tolerance. Okay, these are 2 examples. You can look through them as you please. Now I'm going to show you how to use the multimeter. You're going to want to put it on the ohms setting. Do you see this right over here is ohms? This one is volts DC, this one is volts AC, and this one is amps AC. So we're going to turn it on to that setting. Now if we want to find the resistance of anything, you can see that it is reading 0. Well, we're on our highest setting. On the highest setting, this one will say 0.9 if it's 0. I don't know why it does that. Some of them will say something else like, well, you'll see. This says 0. If it says 0, go down. Keep going down. That was 200 million, 20 million, 200,000. Now this says 6.5 at the 200,000 setting. We'll go down to 20K. This says 6.64. You can see it's getting more precise. This goes 2,000. Oh, it says 0L. Some will say 1 over on the left. That means you need to go up a setting. This is the most precise reading we're going to get. 6.65 thousand. We're in thousands. So 6,650 is the measured resistance of this. Now let's check to see what it should be. It says blue, gray, red, gold. Blue, 6. Gray, 8. Red is not going to be this one. It's going to be the 4th ring. So we had 6, 8 times 100. 68 times 100 is 6,800 with a tolerance of 5%. So if this had been blue, gray, red, gold, you would write blue, gray, red, gold. You would write the value, which is 6.6800, and then you'd calculate a tolerance by subtracting 5%, adding 5%. You'd get 685 is my reading, and you'd say whether it's within the tolerance.